This is Tech Math 3. No, it isn't. It's Tech Math 2. And we're in section 3-4. Now, in most of the sections in the book, we deal with a thing. In this section, we end up using the stuff we learned other places and putting it all together. So one of the skills we're going to need is how to draw pictures. So without a picture, we're totally hosed. And with a picture, we have a fighting chance. So there's no new theory. We'll start with problem number 1. A tower casts a shadow 42 meters long, and the sun is... Say again? Oh, I'm not on the right thing. Yeah, the class is being a little picky today. They want the projector to work. No, normally they don't care one way or the other. It's Friday. Okay, there we go. Problem number 1. Is that better? Slightly? That is a little big though, isn't it? Yeah, that's a little better. A tower casts a shadow. Okay, so I need a tower, and then I need a shadow. So there's a shadow. With an angle of elevation of the sun when the angle of elevation of the sun is 51 degrees. Okay, so that means the sun is here, and that angle has to be 51 degrees. Okay, this is a right angle, unless it's the Leaning Tower of Pisa, then that wouldn't be a right angle. But then that wouldn't be a section 3 problem. Find the height of the tower. Oh, wait a minute, 42 meters. What do you think? Tangent? The tangent of 51 opposite tower height divided by adjacent 42. Tower height 42 tangent 51. Time for the calculator. 42 times tangent 51. Am I in degrees? Yes, I am in degrees. 51.8 meters. So we'll call that, okay, so 51.8 meters, and we call that 52 because that's the number of significant digits we have. Okay, now, why do we have trig? Why trig? And more specifically, right angle type trig. Why do we do that? Why do we have it at all? Okay. As human beings, why do we have anything?
Purpose.
There's some purpose, right? Normally that purpose is to kill off our fellow man. Okay, normally that's, why do you have a pickup truck? Well, in case somebody gets in front of you and you run them down. Why do you have a shotgun in your pickup truck? Well, so you wouldn't hurt your pickup truck when you're running them over. All these things add up, right? So think of yourself, it's now 1480 in Europe, and there's the river, and here's your artillery piece over here on this side of the river, and you want to hit the castle that's over on that side of the river, and things cost money, right? So the shell costs money, the people standing there cost money, the powder you put in your cannon costs money. If you can do the trig and get the shell on the castle the first time, you are a hero because you haven't wasted any money, right? But if the shell falls there or there, then why did I hire you to be my artillery officer? What are you trying to do to me? So if you go and you put somebody there and you do a right triangle like that, and you figure out what this angle is here, and you paste this off there, then you know how far it is to the castle. So the practical reason for having trig is a military reason. the reason we have the military academy at West Point was to teach trig. So we could teach officers how to make forts and to use their artillery wisely and other such things. All right, so that's just one of those historical things. Now, we also use trigs for good stuff, right? So when we were building the castles in medieval Europe, we were using them. The cathedrals that were built during the Renaissance, we were using trig. So we used it for other reasons too. The technology building, we used trig to figure out where it was going to be on the land. All those things are good. Okay, let's go to number 5. Number 5 has a smokestack. It's 190 feet tall. Find the angle of a guide wire which must be fastened to a stack 20 feet from the top of the bottom, which makes a 20-degree angle to the ground. Okay, now I've read it once. I had no idea what it said. Okay, so I have to go slower. So I got a smokestack 190 feet tall with 3 significant digits. I have the ground. Okay, that's good. Find the length of a guide wire which must be fastened to the stack. Okay, so I'm going to fasten it here at 25 feet below the bottom. And when it comes down to the ground, it has a 40-foot angle. That was good. Wasn't that good? Didn't you like that one? Yeah. As I was saying, 40-degree angle. Okay, so what do I know? I know 90 minus 25 is 165. 165 feet. And I want to know the hypotenuse, also known as the length of the guide wire. So that's going to be a sine problem. So the sine of 40 degrees has to equal the opposite, 165, divided by the hypotenuse. So the length of the guide wire, also known as the hypotenuse, is going to be 165 over sine 40. Alright, so 165 divided by sine 40. 256.7. 256.7 feet, and of course we, with significant digits, would round that off to 3, 257 feet, and call that our final answer. Okay. The issue here is that I have to have a good picture. If I can't get a good picture, I'm not going to be able to solve the problem. So picture it in your mind. Oh, look at this. 1, 2, 3, 4, 5 lines of words. And is the picture on the other side? No. Okay. The pathway for a mine shaft is described as follows. The first shaft extends north and down at an angle of 3.5 degrees. Okay, so I'm going to start here. I'm going to call this direction north. I'm going to go north and down 3.5 degrees for 225 feet. Okay. To a vertical shaft, so that's straight down, 125 feet. A third shaft then extends north and down, there's ground level there, north and down at an angle of 6.8 degrees for another 175 feet. What is the total depth below the ground at the end of the third shaft? Boom, that guy there. Also, what is the net horizontal distance from the ground opening to the end of the third shaft. Okay, so I want to find that. Okay, so I want to find the total depth below ground. So that's that guy there. And then I want to also find the horizontal distance, net horizontal distance. So I want to find that number there too. Okay, so that being the case, I'll construct several right triangles. We'll get one here, and now we want to know that side, we'll call it A, and this side we'll call B. All right, okay, we'll use sine first. The sine of 3.5 is equal to the opposite, B, over the hypotenuse, 225. So my B is 225 sine 3.5. 225 times the sine of 3.5. 13.7 feet. All right, so I got 13.7 feet. And then I want to find the horizontal distance, so I'll use the cosine of 3.5 is equal to A over 225, finding out that A is 225 cosine 3.5. And we're going to have 224.6. So A is equal to 224.6. Now, could I do that differently? Okay, nothing's up my sleeve, and we're gonna see if this guy here is going to be able to do it. But when we do that, we're going to lose our video. Okay, so we're still going to get my voice. So there's my calculator. I got it straight up and down, and we can almost see what's on it. Okay, isn't that great? Now, I'm going to take the mode, and I'm going to come out of polar mode, and I'm going to go into rectangular mode, which is A plus BI. Okay, and then I'm going to go to quit, and then I'm going to put in my calculator that I have 225 second function complex angle at an angle of 3.5. Okay, so that's what I'm going to put in my calculator. When I hit the enter button, it's going to change that to the x and y components. Okay. The y component is going to have an imaginary I by it. So it's going to say that the x component is 224.58. 224.58 is exactly what I got doing what I was doing. And then it's going to say that the y component is 13.7, and 13.7 is exactly what I got the other way. So I don't necessarily have to use sines and cosines to solve a vector problem, which this is. I can use my calculator in rectangular mode. And luckily we will go over that again and again and again. Right now, because we're in section 3 of the book, we're using sines and cosines. But later on, in fact, what will happen is that I'll say sines and cosines, but I just put in the polar form and come back with the rectangular form, and you won't even know that I was doing it up there. All right, so back to the next issue. So we have that triangle solved. Now we have to have this triangle solved down here. So these are opposite interior angles. So 6.8 degrees means I have 6.8 over here. Okay, now I want, I have, what do I have? I have the hypotenuse again. We're going to call this C, and D. So I'm going to use the sine function to get the C guy. The sine of 6.8 is equal to C over 175. And the horizontal guy, cosine of 6.8, D over 175. So I'm going to write that C is 175 sine 6.8, D 175 cosine 6.8. I'm going to put that in my calculator. And I'm going to get that the sine value, the cosine value, 173.76, and the sine value is 20.7, and then significant values, significant digits, I really only have 3, so I'm only going to keep 3, 20.7, 173.8. All right, now it's time to add that up. Okay, so now we got the total vertical distance and the total, if I can spell total, horizontal distance. All right, so I've got 13.7, is it 125 plus, yeah, 125 plus 20.7. And horizontal, I've got 224.6 plus 173.8. All right, so now I'm ready to add. We'll call it 159. Yeah, and we'll call it 398 feet. And those will be my final answers. Okay, but I needed a better than normal picture to do such a thing. Okay, so that was 10. Well, let's see. It looks like we need to do 11. Number 11. The right triangle in figures 3.35 shows the relationship between the impedance, the reactance, the resistance, and the phase angle. Okay, so I got all that. What is the reactance? Let's see, the reactance, okay, so problem A. The reactance is 82.6 ohms. The resistance is futile at 112 ohms. Find the phase angle. Okay, so that'd be a tangent problem. The tangent of theta, the opposite, divided by the adjacent. Theta is equal to the arc tangent of 82.6 divided by 112. And now we'll write down our answer. Arc tangent 2080 or whatever it is, divided by 112, 36.4 degrees. 36.4 degrees. Okay, so that's my A answer. B, if the resistance is 225, find the phase angle. Okay, so the resistance is 225. Okay, so we're gonna do it again. B resistance is 225. The reactance stays the same. If it hadn't, then there's no reason to solve the problem. And ohms and ohms. So now theta will be again the arctangent of, we want that theta. Arctangent of 82.6 divided by 112. Boom. 36.4 degrees. 36.4 degrees twice?
You did 112.
Oh. Fine. So what you're telling me, if I put in the same numbers twice, I'm going to get the same exact answers?
Possibly.
Oh, wow. That's awesome. My calculator is going to do that for me? 82. Does it do it for you too? 225. Only on Wednesday? 20.15. We'd call it 20.2. 20.2 degrees. All right. So a problem that's in rate, an electrical problem, we obviously have to do. So, and how many times did you guys have to do that last semester? Over and over again, right? Yeah, circuit analysis class. The corner of a metal plate in the figure below is cut off. Find x and alpha. Find x and alpha. Okay, so I got this metal plate, and I'm 3.60 centimeters over here. What did they cut it with to get 3.60 centimeters anyway? Cut it with a hacksaw by hand? No? Yeah, probably not. Alright, so I'm going to put that in like that. And, okay, so alpha is there, and x is here. Okay, I got it. So, obviously didn't really do it with a hacksaw by hand because somebody was laughing out there. How about a plasma cutter? Can I do it with a plasma cutter? Yeah, I could probably do it with a plasma cutter. Well, not me personally, but somebody could probably do it with a plasma cutter. Well, I think I'll go for x first. What do you think?
Yeah.
Yeah, x first. Okay. X is equal to square root of 2.3 squared plus 1.7 squared equals, oh, I guess I'll do that. Square root of 2.3 squared plus 1.7 squared equals 2.86. 2.86 0069929 centimeters. And then theta is going to be the arctangent of the opposite guy, 1.7 divided by 2.3. Arctangent 1.7 divided by 2.3. And I get 36.4692339 degrees. Now, why did I do that? Anybody know? Well, obviously, we're going to do another calculator demonstration. That's what I did it for. And, okay, so now I'm gonna take my calculator, and the mode I'm gonna put it in is polar mode. So I'm gonna put it in R angle theta mode. Okay, and then I'm gonna get out of there, and then I'm gonna say, well, all this is a vector with an x and a y, right? And so My x component is 2.3, and my y component is 1.7 I. And although that would be a negative number, but because it's going down, it's okay to put it in that way for now. I hit the answer, and what I get 2.8600699929. Exactly what, well, I can see it, you can't see it.
Why put I in there though?
Yeah, and the angle is 36.4692, blah, blah, blah. So I get the same thing. I didn't have to, I now did a rectangular to polar conversion, and my calculator does that without me having to worry about it. So I can do it using sines and cosines and tangents and square roots and everything else. All right, but back to, we have two issues here. First is we need significant digits. So final answer, 8.6 centimeters, and alpha is 36.5 degrees, and we'll call that our final answer. Now back to circuit analysis 1. If I had resistance, that was on my real axis, right? And if I had reactance, that was on my imaginary axis. So the way I show a number sitting here at 1, 1, I'd call that 1 plus I. If I have a number sitting down there at minus 2, I'd call that 1 minus 2I. So I put the I in there to show that I'm on the y axis. So that's why I put the I in. So it's the form, it's the rectangular form of a vector, A plus BI. Okay, back to what we're doing. Does that answer your question, Nate? Why I put the I in? Yeah. Just one of those mysteries. Again, we'll get to that sometime other. What was I doing? That was 13? Let's see. Ooh. Guess we'll do 18 next. 18. Find the length x. Find the length x. Okay, well, I've said it twice. It must be true. That must be what we're looking for, the length x. All right, so I got this thing. Looks sort of like that. All right. I got 180 millimeters there. I got 5.8. No, I don't. I have 85. 85.0 millimeters to there. And when I come this way, I see a 78-degree angle. Isn't that just hunky? What am I going to do with that? All right. I think what I'll do is I'll put a construction line going through the center like that. And then I'd say, if I have a construction line like that, and then one that comes down like this, like that, then this angle right here is some particular amount. I wonder what it is. It's half of 78. What's half of 78? 39? 39. So I got 39 degrees there and there. Okay. And then I look at this guy sitting here, and he's going to be half of 180. So I've got 90 there. 90 there. Okay. Now, I got this guy coming through like that. This guy coming through like this. alternating angles are equal. So if this is 39, that's got to be 39. Okay, so now I know this side, that angle, I can find A. I know that side, that's all I have to do. Once I got A, once I have that A, I have an A there, an A here, and I have a 180, and I just go 2A plus 180, I'm all done. Okay, so I know that measurement's 85. I know that angle. So that looks like a tangent. The tangent of 39 degrees is equal to A, the opposite side, divided by the adjacent side. A is 85 tangent 39. Okay, so 85 tangent 39, 68.8. 68.8 millimeters. Okay, so now 2A plus 180 is going to equal my x that I'm looking for. Yes, it is. So my x is going to be 2 times the answer plus 180. And I got 3 significant digits, so I'll write down 318 millimeters. Okay. It does help when you do the same problem every year for 15 or 16 years. Easier to see where to draw the construction lines and what you're heading for, and knowing if you're going in the wrong direction, all those other good things. Okay, we're going to look at 20 next. Find the width x. Find the width x. Okay, number 20. So I got something that looks like doesn't look like that, does it? Alright, so I got something that looks like that. And I've got 4.500 centimeters. I don't have anything that can measure that close, let alone make a dowel like that. Alright, I got that. I know that this is 60 degrees here. Does that mean this side is 60 degrees too? It doesn't tell me that it is. But if it's not, then I can't solve the problem, right? And then over here, I know this side is 0.750 centimeters. And I want to find x going between there and there. So if all I were to do was find this amount over here, A, and I subtracted 2 of them from that 4.5, I would find x, right? Okay, so if this is 60, then this side, and that's a right angle, then this side has to be 30. And the tangent of 30 is going to be A over 0.75, implying that A is 0.75 tangent 30. And we know tangent 30 is square root of 3 over 3, right? So this would be 0.75 square root of 3 over 3. 0.75 times tangent 30 0.433. 0.433. Now we're going to go 0.75 times the square root of 3 divided by 3, and I get the same answer. So you could do it either way. All right, so now I know what A is. So now x 4.5 minus 2 times 0.433. 4.5 minus 2 times the answer, 3.634. 3.634 centimeters. Okay? But we did have to make an assumption. We did have to make the assumption that the dole is symmetric and that this is 60 degrees on this side. Is that a good assumption? Would you make the dole unsymmetric if you were doing it as a carpenter? Probably not. You'd have the same tool going both ways. You'd use whatever it was you're using. Yeah, exactly. Okay. So that looks good. Guess we'll do 24. Is there another? Oh, look at these other cool ones. So does it go to another page? Yeah, it does. Oh well, can't everything. We'll do the plumbing one, 24, because plumbing's in rate for us, because when we run conduit, that's sort of like being a plumber, except it's not. But almost the same. 24, number 24. In the figure below, find A, the length of advance. Length of advance. And B, those angles. Well, we probably want to find those angles first, right? All right. So B to D, length of advance, if the roll is the roll. Okay, the roll is 20 centimeters, and the offset is 36 centimeters. That's 36 inches, and the travel is 72. Okay, well, that was confusing enough. All right, so we got this picture, and boom, 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 boom. And we got this pipe. And it's starting here at B. And it's going up there to A. Okay, so I got that. And the roll is 20 inches. So roll is A to C. So I have 20 inches right there. All right. And the offset, C to D, the offset is 36 inches there. And the travel, A to B travel, is 72 inches. 72 inches. So this is a three-dimensional problem. And we want to find the advance that's down here. Okay. All right, so what do we know? Not very much, but if I throw in this construction line, I know that this is a right triangle. If that's a right triangle, that does me no good at all.
You know your height.
You
know your height is 36 inches.
Oh yeah, I know my. Oh yeah, yeah, I do. I know my. Oh yeah, I know my height is 36 inches. So I can find. Now, what angles do they want me to find? E, B, E, B, A. So I can find angle E, B, A because down here is E. And I can find it now because I've got this guy and this guy. So angle E, B, A is going to be the sine. So the arc sine of the opposite 36 divided by 72. And that's 30 degrees, right? Okay, so 30 degrees. Okay, so now I've got something. This is 30 degrees. Okay. Knowing that that's 30 degrees, I can now find the green guy right there. I can find the distance B to E. Well, I could have done that before, right? That's just the square root of 72 squared minus 36 squared. So I could have done that before. Square root of 72 squared minus 36 squared, 62.4. 62.4. I know that this is 62.4. I know that this is 20. So my advance, which is B to D, which I'm looking for, is going to be the square root of that guy squared minus that guy squared. Okay, so the square root of, B to D, square root of 62.4 squared minus 20 squared. 60, okay, answer squared minus 20 squared equals 59.1. Okay, so 59.1. What is it? Feet? Inches? Inches. Okay, so this is going to be 59.1 inches. And then we only want one more thing, and we want the angle CBA. Okay, so where is A? A is up there. Where is C? C is over here. C, B, A. Alright, so I want the angle CBA. Right. Okay, CBA. That looks like the arc tangent. No, not the arc tangent. That looks like the arc sine. Is that going to be the arc sine? This is the hypotenuse, 72, right? So, angle CBA, arc sine of 20 divided by 70. 20 divided by 72. Arc sine 20 divided by 72, close parentheses, boom, 16.1 degrees. And with a better picture, I'm sure that would be more clearer. Unfortunately, if I made a bigger picture, then I wouldn't have any place to do the math. And that would be a bummer too. Okay, good enough? Okay, attendance is next. Scrolling down a little bit is next. Okay, good enough? Okay, Control Alt Delete. Now Control Shift